Hello and welcome to Chem Girl. Today's topic is intermolecular forces. Okay, so let's start out with the definition of intermolecular force. First of all, we should not get this confused with intramolecular force, which, as we know, is the bonding that happens within the molecule. So what are intermolecular forces? So according to the book, they are forces that cause the aggregation of components of a substance to form a solid or liquid. So let's simplify the statement. So let's look at the word intermolecular. So if you have studied Latin before, you know that inter means between. So it's between molecular forces, or rather the forces in between the molecules. So some forces we may know already between molecules are ionic forces and covalent forces, more ionic bonds and covalent bonds. So an ionic bond is a chemical bond that is formed between a positive ion and a negative ion. So for example, we have Na plus and Cl minus together. They make NaCl, which is just our common table salt. And an ionic bond occurs between a metal and a nonmetal. So let's look at a covalent bond. A covalent bond is a chemical bond formed by the sharing of one or more electrons. So for example, we have CH4, and a covalent bond occurs between nonmetals. So CH4 is an example of a molecule that has covalent bonds. But overall, intermolecular forces are weaker than covalent and ionic bonds. So let's take a look at some of our intermolecular forces. So first, let's go over dipole forces. So this figure right here shows a dipole-dipole attraction. And typically molecules with dipole movements will be able to attract each other so that the positive ends and the negative ends are close to each other. And dipole movements, or dipole forces, are usually not as, they're usually weaker than covalent and ionic bonds. But one of these stronger dipole forces is something known as hydrogen bonding. So hydrogen bonding is seen when hydrogen is attracted to very electronegative atoms, which are nitrogen, oxygen, or fluorine. So because hydrogen has is a very small atom, it allows the dipoles to become very close. And because, as I said before, a nitrogen, oxygen, and fluorine would be very electronegative atoms, the bond would be extremely polar. So one of the specific characteristics of a molecule with hydrogen bonds is that it will usually have a very high boiling point. And as I was saying before, this is because of the large polarity and the smallness of the hydrogen atom. So because of these two factors, the intermolecular force is very strong, and so a large quantity of energy must be supplied to overcome the interaction and separate the molecules. Okay, so let's move on to another type of intermolecular force, which is called London dispersion. So unlike a hydrogen bond or a dipole-dipole force, the London dispersion force occurs with nonpolar molecules. And noble gases. So let's first consider the noble gases. So let's just take argon. And as we know, argon has a full outer shell. So it has 8 valence electrons. Okay, so for chemistry, we often assume that the electrons of the atom will just be uniformly distributed around the nucleus. But in actuality, we know that an electron moves a lot. So when the electrons are moving, it develops a temporary dipolar arrangement. And another way to say this is it causes what is called an instantaneous dipole. So usually these London dispersion forces are pretty weak and short-lived, but they can actually have a big effect on bigger atoms. So that's why an atom like argon or an element like argon will have a low freezing point. So the same idea is just applied to nonpolar molecules like H2 and CH4, so H2 Okay, so if we look at these structures, we see that they are nonpolar because their movements cancel out, but they don't have permanent dipole molecules, but their principal means of attracting each other is through London dispersion forces. Next, we have covalent networks. And covalent networks are the strongest kind of crystal structure. So one of the examples of a molecule that has a covalent network is a diamond, which is made of carbon. So carbon will attach itself to form more carbons, and that chain will keep on forming. And so on. And some more examples are quartz and silicon dioxide and graphite. So some of the properties of the covalent network structures are that they conduct electricity, they have a high melting point, they're hard because of the covalent bonds, and they are generally insoluble. And lastly, we have the metallic bond, which occurs between delocalized electrons and positive metal ions. And these metallic bonds are what cause the characteristics of metals, which are the metal's strength, malleability, which is that metals are able to be ruled out, ductility, which means you can pull the metal into a wire or a rod, thermal and electrical conductivity, and luster. And any metallic element has metallic bonds, so you have copper, zinc, sodium, lithium, iron, cobalt, etc. Thank you.